Have you ever wondered what object-oriented programming, or OOP, is all about? If you have, you're in the right place. It's a programming paradigm that's all about objects. Now you might be picturing physical objects, but in programming, these are a little different. Think of these objects as containers. They can hold two main things: data and code. The data comes in the form of something we call fields, and the code comes in the form of procedures. So in a nutshell, an object is a little bundle of related data and procedures. This might sound a bit like other programming paradigms you've heard of, and in some ways it is. But what sets object-oriented programming apart is how it uses these objects and their relationships to each other. So you might ask, what makes OOP different? Well, let's delve into its unique principles to understand better. First up, we have encapsulation, the principle that binds together the data and functions that manipulate the data. This concept is the cornerstone of object-oriented programming. It's like a capsule, hence the name, that keeps everything together, making an object a self-contained unit. Consider a bank account, for instance. It's an object that has data like the account number and balance. It also has methods, which are just functions specific to that object, such as deposit and withdraw. These methods manipulate the data, but they're all kept within the confines of the object. This is what encapsulation is all about. It's about keeping the data and the methods that manipulate the data under the same roof. It's about maintaining the tight bond between the data and its manipulator. This principle is not just about organization, it's also about security. Encapsulation, therefore, helps us maintain the integrity of the data by preventing unauthorized access. Next, we have inheritance, a crucial principle that allows one class to inherit traits from another. Think of it as a family tree. Just as children inherit certain traits from their parents, in object-oriented programming, a child class can inherit properties and methods from a parent class. Take, for example, a general class named vehicle. This class might have attributes like color, weight, and methods like start, stop. Now let's say we have another class named car. Instead of defining all these attributes and methods again, the car class can simply inherit them from the vehicle class. This not only saves us time, but also makes our code more organized. Moreover, inheritance isn't just about code reusability. It's also about creating a hierarchy of classes that mirrors the real world. This makes our code more intuitive, easier to understand, and ultimately, more robust. Inheritance, hence, brings about a hierarchy and allows us to model real-world scenarios more accurately. Moving on to polymorphism, a principle that allows one interface to be used for a general class of actions. This concept is a fundamental pillar of object-oriented programming, and it's all about flexibility and reusability. Imagine we have a shape interface with a method called draw. This method is like a contract, a promise that any class implementing the shape interface will have a draw method. Now let's introduce some classes: circle, rectangle, triangle, each implementing the shape interface. But here's the beauty of polymorphism. Each class can define its own unique way of drawing. For a circle, it might mean drawing a round shape. For a rectangle, perhaps a four-sided figure. This way we can call the draw method on any shape object without worrying about its specific type. It's like giving different artists the same canvas, and each creates a unique masterpiece. Polymorphism, therefore, makes our code more dynamic and intuitive. Finally, we have abstraction, a principle that allows us to hide the complexity and only show the essential features of the object. Imagine a car. You don't need to understand every intricate detail of how an engine works to drive. You just need to know how to operate the steering wheel, pedals, and maybe the air conditioning on a hot day. That's abstraction in a nutshell, presenting only the necessary details while hiding the complexity. Abstraction is like a magic trick that simplifies complex systems by breaking them down into smaller, more manageable parts. It's a technique that allows us to deal with ideas rather than events, making code easier to understand, modify, and maintain. In essence, object-oriented programming, with its principles of encapsulation, inheritance, polymorphism, and abstraction, helps us write better, more efficient code. It's a powerful tool that can help us solve complex problems with elegance and simplicity. So are you ready to dive in and start coding the OOP way?